turning up in the break. That's very kind of you all. Yeah, so I am Dan Webb. I'm at Dan Wrong at Twitter. I also work on the web team at Twitter. And today I wanted to talk to you about Flight. The title on the website is very brief, just because I was rushing to grab one of the slots that was in the morning, because I can't think in the morning, so had to be an afternoon one. So yeah, I just wanted to really kind of give an overview about Flight and what it is and why we created it, really. So a couple of months ago, maybe, my colleague Angus, who you probably listened to in the other room earlier on, wrote this blog post introducing Flight. We were really excited about this. This is actually code that runs all of Twitter.com and most of TweetDeck at this point, and quite a few Twitter properties. So we've actually had this thing running and been sort of battle testing it for about a year or maybe longer at this point. We were really excited about bringing it out and showing the world. We anguished over this blog post trying to make sure that it sort of explained all the intent behind Flight, and we put it out into the world and then waited to see what the world had to say about it. And literally, this is no joke, the first comment on Hacker News was this. So obviously the first thing we thought was, oh, for fuck's sake, Hacker News. But like, in a sense, it's a really good question, and I think like it does bear elaborating on. There are a ton of client-side frameworks out there now. We couldn't possibly need one more on the pile. And we did think about this, and we would seek to use something that was out there, if at all possible, and contribute to it rather than creating a new thing. But we felt that what we were trying to achieve was distinct enough from these, and I want to explain a bit about that. So to set the scene, when I joined the web team, it was not long after New Twitter was out there. New Twitter at its time was quite ahead of its game. It was a fully client-side MVC application at the time when I don't even know where the backbone was out at this point, or any of the other frameworks. So it was built on a sort of a homegrown MVC framework, because there wasn't anything sort of big at the time, and doing a lot of really interesting stuff. And like a lot of MVC frameworks, it had the structure that you'd expect. So this isn't real code. What I've done with these code examples is more tried to kind of generically illustrate the kind of conventions that you see in MVC frameworks, rather than writing code for a particular one, because I'm not pointing at faults in a particular framework, just trying to illustrate the kind of thing that we had. So obviously we had models. Models, you can request an object, which is a model. You can call functions to mutate those objects and do actions like following. In our case, and in a lot of cases, these things were asynchronous, so you had to call back to do something with that result. As well as just calling methods directly, you can actually add event listeners, so other objects can listen to follows that happen in the application generically. We had controllers. Controllers sort of typically look a bit like this. You have some kind of URL router that points to a particular controller in action, and inside that we're finding some tweets by actually calling the home timeline method on the user model, and then with those tweets we create some views, and then we stuff those into the DOM somewhere. Views looked a little bit like this. We still use Mustache, and similar to how we used this back on New Twitter. Typically, they render things, but they can also render sub-views as well. So in this case, we're getting all of our tweets, and then we're creating a new tweet view out of those, and then rendering those and putting those into the DOM. So we end up having this structure where controllers would typically talk to the router, would talk to the controller, and the controller would talk to views and models. Views and models. Ooh. I think Jeremy Eshkanas is trying to interrupt the talk. So views talk to models and other views. So there's a lot of relationships, and this is actually a real slide that we had that tried to document all of the relationships in new Twitter's UI at the time. And as you can see, it's complicated. It's there are a lot of relationships and hierarchical relationships and event relationships between all kinds of different pieces. And the thing is I think, it doesn't necessarily look it, but Twitter.com is quite a complicated UI. So this complexity was necessary. There is a ton of stuff going on there and a ton of code needed to run all of that stuff. So that's fine. Like, we need this stuff to be complicated. But what the situation we had is that when we added features, what we were doing is adding more boxes and lines to that diagram and increasing the amount that one engineer would need to understand. They need to really understand most of all those boxes and arrows in order to effectively do some work, because they can't just look at one bit of the code and change it without knowing all of the things that refer to it and knowing whether there would be knock-on effects. So how do we have a complex application with lots of sort of interdependencies, and how do we make it easy for engineers to think about? So no matter how many features you add, it's still just as easy to think about as when you had one control on the page. And the answer really that we went for is we were all about decoupling. We wanted every single thing every single sort of representation in the UI to be completely decoupled and not know anything about any of the other parts of the UI at all. And there are lots of different ways. I mean, in a sense, MVC kind of at least sort of tightens these couplings, so and it gives a structure to the couplings. But we wanted to go further than that. We wanted to make sure that one UI element does not know where its data comes from. It does not know or even care if any other particular components are on the screen. Everything is just completely independent. And this is sort of, I think, where we've gone a step further than most other frameworks in this respect. The kind of pretentious, stupid way of looking at it is cells, really. We want each cell in a body, which is an extremely complex thing, isn't aware of what's outside it. It just listens for changes in chemicals around it and does its own thing. But in aggregate, these cells that don't know or care about the cells next to them create something really complicated. And the way to get to that is the same way that cells get to that components need to have this very, very simple contract with the outside world. And rather than knowing that they've got a hold onto a view object and the views have a render method, and they also have a reference to some other object, and they have to know about the API to that particular object. We want just this really simple thing in the same way that cells listen to changes in chemicals around them. So we're heading for entirely self-contained components. My non-pretentious way of looking at this is if the poo is trapped in the box, then it only smells when you open it. What I was trying to explain here is that if everything is completely self-contained, we don't care what's written in any one component. We can refactor the whole thing as long as it continues to do its job. We can put any old crappy old code in there, and because we can refactor that when we've got time. We don't have to worry about some crappy design decisions in one part of the application having an effect on the application as a whole and not being able to refactor that. So how did we achieve that with Flight? Well, we already, I'm always been a great advocate of making use of what we have and going with the flow of the platform, and in this case the browser, rather than trying to create paradigms that sort of live alongside it. So what do we have in the browser? Well, we have the DOM. And how can we make use of the DOM rather than kind of bash it into shape? Well, the one nice thing, I think, the one elegant piece of facility that the DOM provides is actually events and event bubbling and the way that events can be triggered at certain points in a document structure. And because hopefully your document structure and your markup is actually gives some structure to the application, the way that events bubble up through that structure is a really useful way to carry messages around the application. It's got this inherent hierarchy, so the tweets, the markup for the tweets is inside some markup that represents a timeline, and that markup is inside the body of the page and so on. This is all structure that actually maps to the way this application works, and we can make use of that. We have event bubbling. So we take advantage of all of this, and essentially a flight component, in as simple words as possible, is an object that has a reference to a DOM node. So it's a simple JavaScript object. It has a property called node, and that points to a single DOM node. And there are three things that it can do. It can manipulate that node, so it can change classes on it. It can put new markup into it. It can do change styles on it if you really need to. It can trigger events on that DOM node. So if it wants to alert the outside world to something that's happened within it, then it can fire an event and say, okay, someone clicked me and I think this is, and they mean that they want to retweet tweet ID 55, for instance. And they can also listen for events. They can, anything that they might care about that happens in the outside world, like some new data coming in, or a user clicking on that node or some subpart of that node, they can listen to that event and then and respond. So to get sort of right to the meat of it, I'm not sure, how many people have seen Flight? Okay, I will do this in at a medium pace then. So this is a Flight component. It's essentially quite simple. Where you start when you're reading a Flight component is down here at initialize. Now what initialize will run at the time that an instance of this component, because you can see this like a class, you make many instances of one component and each DOM node gets its own instance of this component. So when that attach happens, when a new instance of the component is made and attached to a DOM element, then initialize is called. And this is where you just normally set up event handlers. So in this case, this is sort of like a generic toggler thing. It listens to a click on the node and just kind of flicks a class. So you'll see we set up the event handler, and then that's the event handler, really simple. And then you can put other bits of state in there and other methods, and basically this is your little bit of code that puppets a DOM element. And that's all there is to Flight, really. This is what you get. But it enables us to kind of take advantage of this decoupling. Your app basically becomes a collection of these components, all not knowing about each other, just all kind of doing their own thing in complete isolation. And the way that you actually sort of structure your app and compose it is basically just by taking a collection of these components and attaching them to pieces of the DOM. So you can say, my navigation component can attach to the top nav, and I'll attach this toggler to some selector, pass in some options for what the toggle class is called. And this is basically how the whole thing works. So the idea is instead of understanding the diagram before and all of these relationships that all point to all different other parts of the application, when you're actually writing or adding functionality or changing functionality, all you're doing is considering one single component at a time. You don't have to understand how the whole thing works. You just have to look at the component you need to change or the component you need to add, understand how that works, and then make your changes. So instead of that giant diagram, you only really need to understand something like this. This is a toggle component. It fires enable and disable events to the outside world, and it listens for clicks. And that's literally all you need to understand. So with that, your poo is trapped in its box. Whatever happens inside that toggle is very localized to that particular component. The nice thing about this, and sort of a lot of this relates to the previous talk on AOP, is that we don't have to resort to mocks for tests. Because everything is so atomic and one component doesn't even care that there might be other components on the page, you have this great environment for tests. You take a single component, one at a time, you fire events on it and check that it does what you want it to do, and then you check that it fires the events that you expect it to have, and just you're simply testing this contract, which is relatively easy to understand. We have a tool for that called Flight.js. It's basically sort of a set of Jasmine helpers that allows us to test these contracts. A small example of that is if we wanted to write assertions about this, we'd just be able to say, okay, describe this component called toggle. It would set up this component. Essentially what it would do is gives you a fresh piece of mockup for every single test. It attaches a fresh instance of that node to it, and then it runs a single test. So there's no test pollution. You're just testing this one thing at a time. You get a fresh instance every single time. And you're basically doing stuff like this. So you can spy on events. So this test is just, if you click it, does it fire the enabled event? And then as you can imagine, you just kind of write a test for each one of those things that we have in our contract here. And you're done. You have pretty nice test coverage. So how do we apply this to Twitter.com and something that is non-trivial? Well, essentially, what we've done on top of this is sort of have this reasonably hard separation between UI components and data components. So what we wanted to do is have UI components whose only job is manipulate the UI. And typically, they take a browser event like a click or a key press, and then they do a little bit of logic to turn it into a higher level, an application event. So for instance, you might have a follow button and a follow button UI component that will sit on top of it. It will listen for clicks and then fire an event called follow, or UI follow in using our naming conventions. And the user ID would be Dan Wrong, for instance. What then happens is we have data components, which are just normal components, just like the one you saw, but their only job is to talk to the server or wherever else you store your data. So they normally sit on the document because in the example of follow, we want to listen to follow events wherever they come from. They can come from anywhere in the UI. So we listen to the whole document, listening for those follow events to come up, and then making the requests. When the request comes back, they fire another event, broadcast an event that says the follow of user Dan Wrong was successful, or it errored, and so on. And then the UI components can listen to the success or error and actually reflect that in the UI. And this is essentially how pretty much everything works in Twitter.com. The nice thing is that, say, if you click the follow button, you also wanted to update your following count on the page, then you just basically link that to the result event. So you add a new component, which is the follow account component, for instance, and you just listen for yes, the follow was successful, and increment the count. But the other stuff that you'd previously written, you don't care about. That could be taken away. It could not be there at all, and everything would still work. No code is required to be changed in the existing stuff. You're simply adding extra behavior on. I mean, what we tend to do further to that is that we implement a logger this way. Previously, we would have calls to our logger code inside all of our models and stuff. So if we wanted to log when a follow happened on the UI, we would actually have a method call that said, log this thing happened. But now, a logger is a component that just watches over the application and just listens for things that it cares about and logs them. It's completely separate to all of our application logic. And it literally just sort of sits here and listens for events just like anything else and sends them to the server. And so to scale, like, I mean, I suppose it looks something like this. More components, more events being fired. But the point is, you don't need to understand this. It's irrelevant, the overview. All you need to understand at once is one component at a time. So the more we add and the more complexity we add, we don't actually add to the mental overhead of being able to work on this system. But that is just our architecture. That isn't the Flight way of doing things. We only prescribe the component architecture and the event mechanism. We don't care what templating you use. We don't care whether you do that templating on the client or the server. We don't make any assumptions based on that at all. We don't care where you keep the state, whether it's in sort of model-like objects or whether you defer all that to the server. It's all up to you. We just give you this way of enforcing this coupling. So I suppose the answer to the original question, why not just use Angular? Well, it's not equivalent to Angular. I think in many ways, I'd call it it's a framework for making frameworks. It's a way of handling communication and decoupling, and you add your own architecture on top. An example of that is this thing that's popped up just recently. Icarus actually sort of adds a model layer by adding some code to components. So instead of the data components that we have, which are quite raw, the data components represent models, and they have change events that you can bind to, and so on. So, and I'd love to see more of this kind of thing. Let's layer different UI paradigms on top, and make more assumptions about different ways of doing things. So it's kind of a bring your own architecture, really. So what's next? Well, we've got a lot going on at the moment. We just got a new logo. It's this F thing down here. There's some T-shirts coming, probably stickers. Hadn't thought much past that, but I think it would be great to actually, because we have this sort of really reusable, really decoupled thing. There's been quite a few components that sort of do more general things that could be used in lots of different apps coming out. There's a component that does local storage, and yeah, a few other ones that are popping up. I'd love to see more of that, and maybe we create a central repo for those. Another thing that I'm really excited about, but we've only sort of thought through a little bit, is we think that this architecture could map to web components in a really, really elegant way. And Polymers just came out, which I love the idea of. It's obviously very new, and we want to keep an eye on that for a while. But I could imagine web components and Flight becoming quite an interesting thing. So if you want to check it out, it's github.com/Twitter/Flight. We have a Twitter account, predictably, which is @Flight. Yeah, I'll be around if anyone's interested in chatting about Flight. We have, we thought, as everyone's going downtown tomorrow, that we'd pick a drinking establishment and sort of post up there. So if anyone wants to come and ask questions or chat about Flight, I'd love to hear how people are using it and whether you hate it or not. I'd love to have a drunken argument about JavaScript me, so anyone into that? Yeah, we'll be at 8, there at 8 in Palace Saloon, right in downtown thingy tomorrow night. And come and chat to me. If you want to come and work with Flight at Twitter, come and chat to me, because we have lots of interesting web roles coming up. So cool, thank you very much.